Hey guys, so today we're going to talk about 4.5, which is direct variation. So direct variation is a very special version of what we're going to eventually get into, which is slope-intercept form. So direct variation means that there is a direct correlation between the x values and the y values. And when I say direct correlation, it specifically means that multiplication is involved. So, or division, however you want to think of it. So in this case, it says a recipe for a mini loaf of banana bread calls for 1 ripe banana for 3 servings. So if you have 1 banana, in other words, you need 1 banana for every 3 servings. Let's make a table. If you have 1 banana, you can have as many as 3 servings. If you have 2 bananas, you have 6. 3 bananas, 9. 4 bananas, 12, and so forth. So what equation describes this relationship? What do I need to do to x to get y? So y equals 3 times whatever x is. I have to take x and multiply it by 3. We could have also written that as y equals x times 3. But typically when we're writing equations, it's going to look like that. A direct variation is a special type of linear relationship, as I mentioned earlier. It's written in the form y equals kx, where k is what we call the constant of variation, and k cannot be 0. So, for example, the first 5 on your homework are going to look like this. It's going to say, tell whether each equation represents a direct variation. If so, identify the constant variation. In this case, y equals 8x. Does that follow this template? Y equals kx. We see it does. And k, in this case, would be 8. So k equals 8. This one, does that follow the format? Y equals kx. In this case, k would just be 3/4. So k equals 3/4. Now this one, does it follow the format? Y equals kx. Well, y is not by itself. So what do I need to do to get y by itself? I need to add 2x to both sides. Y equals 2x plus 0. Well, anything plus 0 is just 0. It's just y equals 2x. So now we see that k is just 2. This one, again, I want to see if I can get it into this template. I need y equals kx. So I need to get y by itself. So let's add 5x to both sides. What's 5x plus 2? It is not 7x. Because y equals 5x plus 2. Because they are not like terms, we can't add those. Now, does that look like this? No, it does not, because I have this plus 2. So we'd say not direct variation. Okay. Now, the majority of your homework problems are going to look something like this. So it might also look like, let's see here, 3x minus 2y equals 0. Again, I got to subtract 3x from both sides. So I get this. Y is still not by itself. I need to divide by -2. So y would equal positive 3/2 x, because a negative divided by negative is positive. Again, that looks like this form. Y equals kx. So in this case, k would be 3/2. That's a lot of what your homework is going to look like for 1 through 5. Okay. On the next ones, it's going to say, what does direct variation look like based on a table? So we notice here, says, what happens if you solve for y equals kx? If we solve that for k. Well, what's happening to k? It's being multiplied by x. What's the opposite of multiplying by x? Divided by x. If I do to one side, do to the other. So y over x equals k, as it shows here, right? Oops. So we take a look at this table. Is this relationship a direct variation? Is there something I do to x to get y, and is it the same every time? And remember, it has to be whatever k is, there has to be a certain number I'm multiplying every time. So 1 times 5 is 5, times 5 is 15, times 5 is 25, times 5 is 35. Or we can use the ratio, as we just used here, y over x. So I can go 5 over 1. Is that the same thing as 15 over 3? Is that the same thing as 25 over 5? Is that the same thing as 35 over 7? We see yes, that does in fact all equal 5. So the constant of variation, is 5 for that one. But they all have to be the same. If one of those was 4, that's not a direct variation. They all have to be the same. So for 6 through 10 on your homework, it'll look like these. So 6 over negative 2, is that the same thing? Let's just do it this way. 6 over negative 2 is negative 3. 3 over negative 1 is negative 3. Negative 6 over 2 is negative 3. Negative 12 over 4 is negative 3. So in every situation here, my k is constant, so yes. In this case, it is direct variation, and k would equal negative 3. Okay. In this one, (5.2) divided by 2 is 2.6. And 10.4 divided by 4 is also 2.6. And 14.3 divided by 5.5 is also 2.6. And last one, 15.6 divided by 6. Is also 2.6. So in this case, again, it's going to be the same. It is a constant of variation. It's the same, it doesn't change. So k equals 2.6 for that one. On this one, I go negative 12 divided by negative 3, which is 4. Negative 4 divided by negative 1, which is 4. 20 divided by 5, which is 4. And 26 divided by 7, that's going to be 4.5. Oops, no, 26, no. I was going to say, yeah, that equals 3.7, I mean. So these are good, but this one makes it not direct variation. So you'd say not direct variation because there is no constant variation. All right. And then 11 and 12, it's going to have a word problem. It's going to say at a summer camp, there's a counselor for so many campers, and you're going to write a direct variation for that. So remember, it's going to have to look something like y equals kx. Well, if it's 10 campers per counselor, that's going to be y equals 10 times the number of campers. So that means when there's 10 campers, there's one counselor. And when there's 20 campers, there's 2 counselors. When there's 30 campers, there's 3 counselors. So this would be x, this would be y, this would be x, this would be y. So I'm looking for the points 110 on the graph, 220 on the graph, and 330. So my graph should include those things. So you look at those. Lastly, it says writing and solving direct variation equations. So you're given the equation as a direct variation. We are going to use that to solve for k. So it tells me, instead of finding out if it varies directly, it's actually going to just tell us it varies directly with x right out of the gate. It says when y equals 6, x is 12. Find y when x is 27. So I have my equation, y equals kx. It tells me that when y is 6, x is 12. So I just plug those in. Wherever I see y, I replace it with 6. And wherever I see x, I replace it with 12. Because x equals 12 and y equals 6. And now to solve for k. Well, what's happening to k? It's being multiplied by 12, so I divide by 12. What I do to one side, I do to the other. So k equals a half. Cool, so that's my constant of variation. I solve for k. Now, I'm going to use k to find when x equals 27. So again, I have y equals kx, but this time, I know what k is. K is 1/2. And x, it says, is 27. So times 27 it's going to be 13.5. There we go. So when we solve for y, when x equals 27, it's going to be 13.5. And that's how you do those. And that is 4.5 direct variation. Let me know if you guys have any questions. Thanks.